partial fraction. This is another strategy or technique of integration if the other previous techniques do not work. So right now, you already have more or less a lot of techniques when you do integration. So if one doesn't work, then try the other techniques that you know. So how do you apply integration by partial fractions? Suppose you have this, and I think at the beginning you found out that this cannot be integrated using the techniques that we previously know. So again, how do we do this one? We are to break this down into partial fractions. Now, for you to understand the idea of partial fractions, I'd like you to have this easy or simple example. 1/3 plus 1/2. If you recall your basic mathematics, you are told to find the LCD, by which the LCD is 6. So 6 is simply like multiplying 3 and 2. Okay? And your numerator would depend on what your LCD is. In other words, the denominator seems like a product, all right? A product of two factors, by which these two factors are separate fractions. They were separate fractions at the beginning. When we found the LCD, we just multiplied the separate denominators, thus getting 6. In other words, this x squared minus 4, when we try to factor it out, will just be, we can predict that as partial fractions, this could come from two different fractions, each with a denominator of x minus 2 and x plus 2 respectively. But we are not certain what the numerator is. Therefore, we can say that from this given, we could reduce this, we could decompose this into partial fractions as such. All right? So we have integral of a certain numerator which we do not know over x minus 2 plus integral of a certain numerator, another numerator over x plus 2. So this is coming from this particular concept. So we're going backwards then. All right? So we can predict that the integral of this will just be equal to its decomposed partial fractions. Okay? So before we can solve this, we need to find the value of your a and the value of your b. That's the only time we can find the derivative, the integral of each term. So how do we solve for a and b? All right? So what we can do is we can just take this rational expression, equate it to the two partial fractions. Okay? And the rule of the thumb, if you see fractions, always find a way to eliminate the denominator, and the way to eliminate it is by multiplying both sides by the LCD. All right? So if you multiply both sides by the LCD, all of these will be cancelled, therefore this becomes 1. And then for the first partial fraction, x minus 2 will be cancelled, therefore a will be multiplied to the remaining factor, x plus 2. Similar reasoning for the second partial fraction, x plus 2 will be cancelled, therefore b will be multiplied to the remaining factor, x minus 2. All right? And then from here onwards, we have to find a way in order to eliminate one to solve the other. For example, if we wish to solve for b, we have to eliminate this. Therefore, to solve for b, this must be equal to 0, so that this times a, if this was 0 times a, this will totally be gone. So we can assume here x to be equal to negative 2, because this is the value of x that will make this 0. So once we have assumed this one becomes 0 already, all right, leaving us with 1 equals negative 2 minus 2 times b. Simplifying it, we get a b equal to negative 1/4. All right? Now, similarly, to solve for your a, so we have to set this equal to 0. And the value of x that makes this 0 is actually 2. Therefore, we know that this will now be 0, and thus we can now simplify it as 1 equal to the value of x, which we assumed, which is 2 plus 2, times your a. Okay, solving it and simplifying it, we now get a value of a equal to 1/4. Now, since we have already found the value of a and b, we can now substitute it in our partial fractions. Remember, we can only find the derivative once we have found a and b. And now we have found it. So substituting it, and since these are just constants, we can just put it outside to make it simpler. So we can write it this way. All right, and this time we can now find its integral. Remember that you need reverse chain rule for this, assuming this is your u. But if you are familiar with it already, then you would know that the integral of it will just be ln x minus 2 minus 1/4 ln x plus 2 plus c. Now, before we proceed to that, before jumping into this conclusion, you have to be careful with the coefficient of the x, because if the coefficient of the x here is not 1, then it's not the same as this. There must be something else multiplied if the coefficient of x is not 1. That's why you have to do reverse chain rule to check it out. Okay? So continuing, 1/4 is common, so we can factor it out. And according to the laws of logarithm, if you have this expression, this will just be the same as logarithm, natural logarithm of x minus 2 over x plus 2. Review your laws of logarithm. Okay? And this is now the simplified form. And that's how we integrate using partial fractions. So just understand the idea of partial fractions, breaking it into two separate partial fractions, solving for the numerators, and then proceeding at finding their integral. Let's have another example. Suppose we have this. So for this one, your denominator is x minus 1 times x minus 2 squared. So we assume this to be x minus 2 times x minus 2. So again, based on our previous discussion, we can predict that this is coming from partial fractions with denominators such as this, added together, resulting to this one. Okay, so we can just say a over x minus 1 plus b over x minus 2. However, since this is squared, there must be another partial fraction here. So this would be plus c over x minus 2 squared. All right? Therefore, if this was x cubed, for example, then we will have a plus d over x minus 2 raised to 3. So depending on what the exponent is, your partial fractions will be expanded further. So if there are denominators with powers, so you start with the power of 1 and then proceed plus another partial fraction with the second power. Next, plus another partial fraction up until you reach the exponent from the given. Alright? So just remember that if the exponent is not 1, then you have to gradually increase it, adding partial fractions by doing so. Okay? So as we continue, remember to simplify this, multiply all by the LCD, which happens to be this. Alright? So for this one, everything will be cancelled, thus you will get x. For the first partial fraction, only x minus 1 will be cancelled, leaving you with x minus 2 squared times the numerator, and so on and so forth. Alright? So here we now proceed at solving a, b, and c. So you decide first which one you wanted to eliminate. So in my case, I assumed x to be 2, therefore I wanted this to be 0. So I can solve the other variable. Now it happens that if x is 2, this will be 0, as well as all those with x minus 2 will be 0. Therefore, this will be 0, and the second will also be 0, because this has an x minus 2, leaving us with x and c times x minus 1. So we just substitute the 2 to the x and to this. That gives us 2 equal to c times 2 minus 1 is 1. Therefore, c is equal to 2. Alright? Now, let's proceed at solving for the other variables. So, for the other numerator. So, for the other numerator, decide again which one you wanted to eliminate. So, let's say we wanted to make this 0. So, we assume x to be equal to 1. Therefore, all terms with an x minus 1 will be 0, which tells us that the middle and the last will all be 0, leaving us with x equal to this. Okay? So, this is now substitute x to 1. Substitute 1 to x rather, equal to a, and then 1 minus 2 is negative 1, raised to 2 is positive 1. Okay, so this leaves us with a equal to 1. Now we are now left with one last denominator, which is c. Now, in this case, I cannot use 2, I cannot use 1 because all of these will make the middle one 0. So what are we supposed to do then? We can just assume any value of x. At this point, you can assume any value of x. But if you want things to be simple, we can assume something that might not be difficult to substitute. So in my case, I'm assuming x to be 0. So that it's easy to substitute, it's easy to simplify. So if x is 0, so putting 0 to all the x's here, this leaves us with this. So 0 minus 2, that's negative 2 squared. 0 minus 1, that's negative 1. 0 minus 2, that's negative 2. 0 minus 1, that's negative 1. Now, simplifying this, we'll have this expression. And remember, a while ago, we already found c and a. So we have to substitute it here to leave c, the unknown. So we can solve for its value. So substituting a and we substitute a and c rather to leave b, which is the remaining numerator which we do not know yet. Okay? Substituting a and substituting c leaves us with this. Simplifying it further, thus we get b equal to negative 1. And now we have all the numerators. We are now ready to proceed. Substitute the a, the b, and the c to our partial fractions. And then just perform the integral. So this will now be ln of x minus 1. This is negative 1 when we put outside. That's why we have minus ln x minus 2. For this one, we cannot do the same thing. However, we can actually write this as, or we can do reverse chain rule wherein our u is x minus 2. Therefore, we have to find your du. So du will be equal to dx if this is our u. And then you try to do your reverse chain rule until you come up with this expression. So this will be 2 will be put outside, so that will be 1 over u squared. And then putting it on top, doing your integral, adding 1 to this over the result of adding 1 to your exponent. Therefore, when you simplify, this will just be negative 2 over x minus 2 plus c. And this is now your resulting integral. So I'm now assuming that the basic integration has already been learned, so I will not explain it further. So this is basic integration. That's why I'm not showing the other steps, because this should have been done. Now at this point, I'd like you now to answer these 3 examples, the same with part 3, and then after answering each, you can proceed to the video and check on the answers. Okay, and that's all for part 4.